So this review that we've set up in a fun and entertaining way is here to basically get you to look around at the different things that we've covered so far. Concept 2 is factoring. Concept 3, absolute value graphs. And you got to look at these. Absolute value graphs are graphs of the absolute value. And that might seem like it's obvious, but according to what I saw today in class, that wasn't always, we didn't digest all of that. Number lines are just that, a number line where you've identified certain things within the number line, a range of values that make a solution. Now this is also going to involve an absolute value because the absolute value will show up in a couple different ways, and we'll take a closer look at that. Graphing inequalities, which is greater than or less than, also incorporated in the number lines. So something to keep that in mind. And then solving inequalities. So inequalities are in basically these last three. So you can't just look for an arrow pointing one way and say, oh, it's this category. So we start to look, and we have this large stack of cards. I'm going to have a hard time making them all fit. I haven't actually looked at these. But this is what I'm talking about. There's an inequality, there's an absolute value. This is going to produce something on a number line. We're going to split it into two different things and go a couple different directions with it. Now these graphs here, these are shaded a certain direction. The gray and the black doesn't necessarily mean one is one and the other is another. It's a shaded region, so this is going to involve an inequality with both a y and an x value. Okay, so this kind of falls into the same category of these here, so I'm going to keep that together here. This type of problem here, and it's probably the easiest one, is y and x with an inequality. It's going to be something that'll be shaded in that direction there. Okay, so as we look through a bunch of these types of things could actually be graphs that are shaded in one direction or another, but they could also be something that is a solution for an inequality type problem. So I'm going to put all these guys together, anything that looks like a number line, I'm going to plop them together, and here is something that's going to be factored. So in fact, take a look here. Yes, success. I'm just going to do it because I found it. If you look closely, and I'm just kind of going through some things here, first thing I looked at was that 5x and x is going to give me that 5x squared. And that a 2 and a negative 2 is going to give me a negative 4. Now that doesn't guarantee it's going to be the thing. But if you look at the outer term and the inner term, the outer term is going to be negative 10x. The inner term is a positive 2x. Put those together, that's going to give you a negative 8x. So what we would do on here, we'll get it out of the way. The factoring, we're going to put a P and a C together because that's P and that's C, and we're going to say, how did you know? One thing you can do, and I don't want to say this is how you do it because this is the opportunity. This is where our common core sort of shows up. You're going to need to explain yourself to some degree, and you're going to be able to need to say that here I'll show you how I know, and it's not just because they're equal or just or whatever it is, the lingo that you guys are down with these days. I would say FOIL it. There, 5x plus 2 times x minus 2. And then show me the process. How do I know? Well, I'll show you how I know. 5x squared, the outer term is a minus 10x, the inner term is a plus 2x. And the last is going to be a minus 4. That gives you 5x squared minus 8x minus 4, which is exactly what you had to show. Okay, and as you go through, now we can kind of, anytime we see a factoring problem, we can put it out of the way. Here's an absolute value, or an inequality. I'm sorry, an absolute value. So these three guys are the three shaded regions that are going to show up and look something like, ooh, I'll do it here. Let's look at this one. This is one of the easier graphs. And maybe because of that, I'll get a different one. Okay, so I'll look at these guys here in a bit. Look at that up there. Inequality, we'll get to that in a second. Here, something down like this is going to look like these. This is just an inequality with no absolute value. Oops, there it is. And something like that is going to give you a result that looks something like this. Okay, I've got that. That's probably the easiest one. We can do a different one. Here's one that's going to be a little bit, well, that'll go with these. Factoring off to the side, blah, blah, blah. I might have enough here. This is the one. Okay, I'm going to grab this guy here and say that one involves an x and a y, and it's going to result in a graph that looks kind of like that. If I move the 5x over, okay, I move the 5x over, and what that'll do It's giving me a 3y is greater than a negative 5x plus 15. Okay. Now we do that, we're going to divide by 3, divide by 3, divide by 3, and I've got a y is greater than a negative 5 over 3x plus 5. Once you get it here, and that's like the one I said, the easy one, it was already set up in that way. So you have the opportunity to look at the easy ones. I'm going to take that 5 and look for something that has a y-intercept of 5. And it's hard to see in some cases, but you can see over 1, 2, 3. That's actually the answer for the easy one. These two both are going to have a y-intercept of 5. This one's easier to count. 1, 2, 3, 4, 5. And the other one, we can just kind of trust me on that one. Negative 5 over 3 then, both of them happen to have a slope of down 1, 2, 3, 4, 5 and over 1, 2, 3. Okay, same thing here. The difference here is that this says y is greater than. Okay, don't look at the arrow and say it's pointing to the right, so we'll take that one. You should always look at this and say y is greater than means up. Now in this one particular case it does mean this side, but half the time it's going to be something different. You're going to have to trust me on that one. I'll show you another example at another time. But that shows me that D and K are our solutions. So we would go to our graphing inequalities, put D and K, and that would be the D here and K there are the solutions. And how do you know? And I showed you basically the work that I showed you would be the evidence. So solve for x, comment on the y-intercept of 5 and the slope of negative 5 over 3. Yeah, you know what, let me just show you this. We're running out of time on what we can use here. Other things to look at here. You look at your absolute value or your absolute value graphs. Okay, all of these are very different. Some of them are kind of similar, like these two here look the same because they both have a slope of 2. Over here, these are both upside down, so these are both going to be negative. But that one there is the only one with a different shape. So if you kind of look through the ones that you have, there's only going to be one that's not only negative, but has a fractional number out in front. And G, G, and X then are a match. Okay, and saying that basically, and defending it in such a way that you can say, well, first of all, the vertex is back 3 and up 4, negative 3, positive 4. You can see that from your vertex, your H and K. But also it's upside down with a slope of negative 1 over 2. Negative 1 over 2. So any of these are the types of things that you can do absolute value graph that you can show your how you know type of thing. And your number lines, when you're given something like this, for example, I'll do one more here. This is the type of answer we're looking for, and specifically, what is it that we would get here? I would work on getting the absolute value by itself. So start by moving the 1 over. You subtract 1 from both sides, and you end up with a 9 on this side. You have a 3 times the absolute value, x minus 2 is less than 9. We'll divide by 3. You could also distribute that 3, by the way. X minus 2 is less than 3. It is here where you split this into 2 separate terms, or 2 separate equations. X minus 2 is less than 3, and x minus 2 is greater than negative 3. You need to consider a positive or a negative 3 because the absolute value is going to make it positive anyway. When you consider the negative version of what you see, you need to turn that arrow around. Okay? In both cases, we're going to add 2 to both sides. So I got x is less than 5, and I got x is, adding 2, greater than negative 1. Okay? So when you set it up, your negative 1's on this side, your 5's over yonder. You've got open circles. X is greater than negative 1, you've got an arrow going this way. Less than negative 5, it's an arrow going that way. Okay, and I seem to have hidden all of my different ones. This is not it. If I think I've wasted enough of your time here. If you were close to being done, then in theory that might have been able to finish up the ones you were looking for. If not, I apologize. Have a great weekend.